Okay, for the next part of the sprite tutorial, we're going to talk about collision. And so far, we've only discussed very basic collision, which was whether the basically the player sprite could collide with anything or not, and if so, he simply stopped being able to move. We're going to talk about some more complicated types of collision now. So I'm going to do something different here for a minute. I'm going to try and explain sprites without using MegaZeux. So think of this table as the board, and these squares here, these puzzle pieces, think of these as the sprites. When you're playing the game, this is how you think of the sprites, as being on the board together like this, but this isn't actually how it is in MegaZeux. In MegaZeux, it works more like this, with each sprite taking up its own layer on the board. And the sprite can move around in its layer, and it never actually touches any of these other sprites. They all exist separately on their own layer above the board, and they're able to pass completely over each other because they never actually touch. When you set up sprite collision, you're just getting the illusion that they're touching, because essentially MegaZeux is looking for when the edge that you have defined as the collision edge for two sprites has come into contact, or basically come into the same X position. So you never actually get sprites touching one another. You only get the appearance that they're touching one another. Checking for sprite collision is initiated by this if command here. So if sprite colliding, and then the given sprite number at the given X and Y location, then it goes to the label. And in actual code, it looks like this. If sprite colliding, and the sprite number in this case is the reference to the counter player, and if it's colliding at 0, -1, then return. What those X and Y numbers actually mean is collision happening in a direction in reference to the given sprite. So let's say the player sprite is this smiley character here. So 0, -1 would be one space to the north, right exactly where my blinking cursor is right here. Think of it like this. If you were to move the sprite from its current position, and its current position is 0, 0, if you were to move it one space over and one space down, would it be colliding with something? That's how you should think of those X and Y numbers that you're giving that command. And I will point out again that when you are checking for collision, you are checking for collision in the sprite's boundary box, not in this sprite's physical representation on the board. So if you have referenced a boundary box that is different than the sprite size itself, like one of these examples here, it's going to check for collision only in those areas. So I guess going back to this example here, this would be checking for collision to the south, to the north, to the west, to the east, and then in this example it would be colliding at 3, 1, 3 over and 1 down. And also I want to point out again that when a sprite is checking for collision, it is checking for collision in every single character within the boundary box. So each one of these blocks here is going to be asking if it is colliding. If you say to the north, and you move to a spot where the sprite is somehow gotten over a piece of custom block like this, then this would be colliding at -1 or 0, -1, because these blocks down here are colliding to the north. Alright, so for the purposes of demonstrating sprite collision, I've changed the collision width and collision height of my player sprite to the same size as his representation on board. So it's 2x and 3y, 2 wide and 3 tall. Alright, so I've set up a demonstration of some collision down here. Sprites can only collide with other sprites or custom blocks. That is the only thing they collide with. They will ignore everything else on board, robots, trees, you name it. Anything else on board besides custom block gets treated like floor. It passes right over it with no collision. So for an example here, I set up a custom block right here, and then these two objects are robots that create sprites in the location that they're at. So it just sets a sprite to the exact location it's standing in. So basically these robots will be turned into sprites when the game starts. And I named the blue one Sprite 4 and the purple one Sprite 5. So when I walk into them, sprite collision is happening, and it's showing me that I'm colliding with the custom floor, which is -1, and also Sprite 4 and 5. And then if I go like this, now I'm only colliding with the custom floor. Now I'm colliding with Sprite 4 and the custom floor. Now I'm only colliding with Sprite 4 and 5. You get the idea here. So if you open up the help file and go to the section on counters and find the section on sprites, you'll notice the first two are related to collision. So sprite collisions is the number of things that the sprite collided with. So sprite collisions is the number of collisions that took place when the if sprite colliding command was used. And then the sprite collision list is a list of collisions that took place. Okay, so when I collided with the custom floor and sprites 4 and 5, what it did was set sprite collision list 0 to -1, which is the custom floor. And one thing I want to note here is if a sprite collides with custom floor, it always places the collision between the sprite and the custom floor in sprite collision list position 0. So if a sprite collides with custom floor, then sprite collision list 0 will always equal -1. And then any other sprite collisions will be listed in subsequent counters. So sprite collision list 0 equals -1, and sprite collision list 1 equals 4, and sprite collision list 2 equals 5. And then it sets the sprite collisions counter to 3 because I collided with 3 different things when that if sprite colliding command was used. And the way that I showed that on screen just a second ago was with an if statement. So if sprite collisions is greater than 0, then go to the subroutine show, which is down here. And then it goes to the label show sprite collisions, and then sprite collisions is with an ampersands, so that becomes a number. So it goes to show 1 if I collided with 1 thing, and then show 2 or show 3 if I collided with 2 or 3 things. And then it just shows the appropriate sprite collision list counter. So if I collided with 1 thing, it shows the value of sprite collision list 0. If I collided with 2 things, it shows sprite collision list 0 and 1. And then if I collide with 3 things, it shows me sprite collision list 0, 1, and 2. And then it goes back out of this, that subroutine and continues on with this program. So testing this again, now you know that's how this works. Another way you can initiate collision detection within a sprite is to use this counter here, sprite number collision list. So setting this counter to any value will perform a collision test on the given sprite at its current location. So what that means is if you set sprite, and in this case I'm using the ghost sprite, which is the non-playable character, not the player itself. So I'm setting this ghost sprite collision list counter to 1, and that performs a collision test on the ghost sprite. And so I'm checking it by saying if sprite collisions is greater than 0, then go to the subroutine show. So, and the rest of this follows just like the player sprite did. It just goes down here to the show subroutine and goes to either show 1, show 2, or show 3 for however many collisions it's picking up on. So if we test that, it looks like this. So when I walk into the ghost sprite, he shows a 1 because the player sprite is 1. And then if I make him follow me over here, he is colliding with sprites 4 and 5 right now. If I make him walk up, now he's colliding with the custom block and sprites 4 and 5. Okay, I want to show you a quick example of using the collision detection to perform an action in the game. So I set up a little example here. So if I walk up to this line of objects here and touch them, I get the message, press enter to take sprite 4. And then when I press enter, I get a message that says, you got the 4th sprite. And then when I go out of that message, the 4th sprite has disappeared, so I've picked it up. I want to show you how I set up this example real quick. So, when player sprite is colliding with something, it goes to the subroutine check, and it does that for any of the 4 directions. And check, ignore this here, check creates a short loop that loops for the number of collisions that have taken place with that sprite, and asks in every time it goes through the loop once, it asks if sprite loop count equals 4, then go to the label take. So let's go through this line by line. Loop start, if sprite collision list 0 equals 4, then go to the label take. Now remember, this is the first time we're going through this loop, so loop count equals 0. And then loop 4, sprite collisions minus 1. Now we've collided with 3 objects when I walk into that line of 3 objects, the custom floor and the sprite 4 and 5. So it's going to set sprite collisions to 3, so it's going to loop for 2 more instances. So it's going to go back to loop start and increment loop count by 1, and then it's going to say if sprite collision list 1 equals 4, then go to the label take, and then it's going to go through this loop one more time and increment the loop count counter to 2, and it's going to say if sprite collision list loop count, or if sprite collision list 2 equals 4, then go to the label take, and if sprite collision list 0, 1, or 2 never equaled 4, then it goes back to top. But if one of those counters did equal 4, then it goes down here to take, and it gives you the option to press enter to take sprite 4. So if you press the enter key, then it goes to the label took and send the robot sprite 4 to got, and then it goes back to top. So hopefully that makes sense. That was a really detailed, long explanation for a very short, quick, simple action. So if it sent the robot sprite 4, which I named this one sprite 4, the label got, it just brings up a message that says you got the 4th sprite, and set sprite 4 to off, and then the robot dies. Because remember, the robot is also in this spot right here, and it needs to disappear in order to appear like it has been picked up. Since I've got this little demonstration running now, I should mention a feature of MegaZeux for drawing sprite-based games that have sort of a top-down or three-quarter perspective like this one. And this feature changes the draw order of sprites so that sprites that are lower on the board appear above sprites that are higher on the board. So that's what I have set here. So if you see right now, the skeleton is in front of the ghost, and if I walk up here, he's behind the ghost, and if I come down here, he just pops right through him. So I've set the counter sprite Y order to 1, and that means that if the sprite's collision Y is lower than another sprite's collision Y, it is drawn above it. So that's how that works. And that counter is right here, set SPR for sprite, and then underscore Y order to 1. And so that makes it so that generally, normally without that set, sprites are drawn on the board lowest to highest. So sprite 0 is the base, sprite 1 is drawn above sprite 0, sprite 2 is drawn above sprite 1. So that just changes the order of when the sprites are drawn around. Very handy to have for a game like that. So another counter that's related to collision for sprites is the collision check counter. It's just sort of abbreviated here to CC or C check. So if sprite collision check is set to 2, then basically the MegaZeux won't draw any blank sprites, and it won't allow them to collide with anything on the board either. So what I mean for that is, let me give you a quick example here. So let's say that I was using this tree here as a sprite. So you have to define the sprite's parameters as a square, right? So even though you're not using all this space around the trunk of the tree, it's still part of the sprite. But you really don't want this part of this sprite to collide with anything. Say if this tree was walking around, this is a horrible example, but just bear with me. You wouldn't want this tree colliding with anything down here if it was moving around, or if anything moved into it. So if you set collision check to 2, then that won't happen. Also, if you set collision check to 1, that won't happen either. But collision check 1 is only checking for character 32s, which are this character right here, which is basically blank spaces. And then collision check 2 checks for blank spaces and checks for any other characters that are within the sprite that are also blank, and doesn't draw them as well. So collision detection in a game like this right now is fairly simple, but if this was a real game, it could get quite complicated when you have a lot of sprites that are all checking for collision, or a lot of robots rather that are all checking for sprite collision, and you have a lot of systems running at once. There are some things that can make sprite collision more difficult, and I want to talk about those real quick. The first thing I want to point out is that you need to have the commands counter set sufficiently high. So by default, the commands in MegaZeux are set to 40, which means it will run through 40 commands or 40 lines of code in the program before the cycle ends and the next robot gets its chance to run. So what would happen then potentially is if you called this command here, if sprite colliding, and it set these counters for you, and then the robot stopped running and the next robot began running, these counters would no longer be valid when the robot that you originally set these counters up for got a chance to run again. So the next robot in line would actually get a chance to also run, and it may use the same command if sprite colliding and set these counters to a different value before this robot gets a chance to come back and check these values. So basically every robot in the game uses the same counters, sprite collision 0, sprite collision list 0, sprite collision list 1, sprite collision list 2, and so on. All of the sprite collision list counters and the sprite collisions counter are the same counters for every robot. So every time you use the command if sprite colliding to check for collision, every robot in the game is using the same set of counters. So these counters are only valid to this robot during its cycle that it's running. Once it stops running and a different robot begins to run, it may change these counters to different values, and then they're no longer valid to any other robot trying to use them at that point. So on that same note, you also need to make sure you don't have any cycle-ending commands in your code between when you use the command if sprite colliding and when you go to the spot where you are actually checking those counters. If you did have any cycle-ending commands in your program between those 2 points, then you would have the same issue that you would have if the program stopped running for a cycle and the next robot ran. If you had any cycle-ending commands in there, then those values would no longer be valid because another robot could have a chance to set those values or those counters to a different value. Okay, that list of cycle-ending commands, you need to come over to the Digital MegaZeux forums to find that. And once you're here, so actually, let me show you how to get there. So first you go to digitalmzx.net, like so, and then you come here to the forums, and then you would search for either list of cycles and commands or list of cycle ending commands, one or the other, and then just search. And while you're at it, you should read this pinned article here called Wait for One versus Cycle One, which is a very good explanation of the difference between the commands Wait for One and Cycle One. But if you come to the debate here, you can find this list of cycle ending commands made by a fellow MegaZeuxer who put in a lot of work in MegaZeux, making it what it is today. So you can come to this list and you can look through. It's a long list. All of these commands end a cycle, and there's some special notes here at the bottom that you should read up on too that affect the usage of the command and whether it ends a cycle or not. So if you use any of these commands during your game, in between when you called the command if sprite colliding and when you're checking the sprite colliding counters, those sprite colliding counters will not be valid because you will have had a cycle already go through once already, and those counters will most likely be changed. So that could be a reason that your program is not working correctly. If you're having that problem, you would want to check that. Alright, so hopefully I've been thorough enough in explaining sprite collision to get you started. I'm sure there's probably more things I need to explain that I may have forgotten, but if that's the case, then I'll just have to do a follow-up tutorial video later because I can't think of anything else at this point right now. So good luck. I hope that you were able to get out there and make some cool sprite-based games. I'm going to explain some more concepts here and some more upcoming tutorials, so stick around if you want to learn about how to attach sprites to each other so you can walk around carrying something, how you can make a sprite solid yet not solid so you can have collision on a sprite that you can actually still walk through, how to do some simple sprite animation, and how to duplicate sprites. I'm going to explain those concepts too coming up before I'm done with the sprite section of the sprite tutorial. or before I'm done with the Sprite section of the MegaZeux tutorials. Thanks very much. Bye.